In this video, let us find the value of k, but mind you that our k does not equal to 0. So from here, let's have it to be solution. So when you have k to the power of 6, that equals 2 to the power of 6, let's take this k to the power 2 to the power of 6 to this side. So we are going to have k to the power of 6 minus 2 to the power of 6 equals 0. Then from here, let's simplify this as k to the power of 2 times 3 minus 2 to the power of 2 times 3 equals 0. Then when you have a to the power of m times n, this can be simplified as a to the power of n, then in parentheses to the power of m. Applying it here, we can have here to be k to the power of 3 in parentheses to the power of 2 minus 2 to the power of 3 in parentheses to the power of 2 equals 0. And this has power 2, this has power 2. When you have a square minus b square, we call this difference of 2 square always equals as a plus b in parentheses times a minus b all in parentheses. Applying it here, so we are going to have this to be k to the power of 3 plus 2 to the power of 3. And the reason is that our k to the power of 3 equals a, our b equals 2 to the power of 3. And this will be equals k to the power of 3 minus 2 to the power of 3, everything equals 0. So from here, we have this, we have to apply something we called zero product rule. Zero product rule. And that one says that when you have this, is either we have k to the power of 3 plus 2 to the power of 3 all in parentheses equals 0. For this expression to be equal 0, or we have k to the power of 3 minus 2 to the power of 3 all in parentheses equals 0. So let's define this as case 1. Let's define this as case 2. Now, from here we have a to the power of 3 plus b to the power of 3. From the algebraic expression, this we call the sum of the two cube, and this equals a plus b, all in parentheses, times a square minus ab plus b square. So from here, we are going to have this definitely to be k plus 2 times this will be k square plus 2k plus 2 square all equals 0. So we have this guy here to be k plus 2 times k square plus 2k plus 4 equals 0. We have k plus 2 is either equals 0, or we have k square plus 2k plus 4 equals 0. So from here we have k equals minus 2. Now let's define the following parameter. This, our a to be equals the coefficient of k square 1, our b to be equals 2, then our c to be equals 4. Applying the quadratic general formula, our k will be equals minus b, positive or negative, square root of b square minus 4ac over 2a. So from here we have k. This is minus 2, positive or negative, square root of 2 square, 4 times a, 1 times c is 4 over 2. So from here we have k minus 2 positive or negative. Here 4. Then we have 4 here. We can factor it out to be 1 minus 4. All divided by 2. So we have minus 2 positive or negative. Here will be 4 multiplied by minus 3 over 2. Then we have minus 2 positive or negative root 4 times root 3 times root of minus 1 over 2. Then when you have this, root of minus 1 equals I in a complex number. So we have minus 2 positive or negative. 4 is a perfect square. 2 times 2. Here will be root 2. Here will be 2 times root 3i over 2. Then dividing through by 2 from here. So what we are going to have will be this 2 divided by this 2 will be equals minus 1. Positive or negative. Here will be 1 multiplied by this root 3 will be root 3i. So we have to be equals minus 1 positive or negative root 3i. Now going back to case 2. So our case 2 is a to the power of 3 minus b to the power of 3 will be equals a minus b all in parentheses times a square plus ab plus b square. So from here we are going to have here to be k minus 2 times k square plus 2k. Then from here will be plus 2 square equals 0. So from here we have k minus 2 equals 0, or we have k square plus 2k plus 4 equals 0. So from here we have k equals 2. So from here we are going to have this as a, the coefficient of k square 1, b 2, c equals 4. So we have k to be equals minus 2 positive or negative square root of 2 square 4 times a 1 times c 4 over 2. So from here to we are going to have k to be equals minus 1 positive or negative root 3 multiplied by I. K equals 2. The first is k equals minus 2. Then we also have k 1 positive or negative root 3i.